Good evening, sir.
Evening.
Can I have permission to record, sir?
Okay. So, one eye.
Richie CDIAM.
Okay. Alright. So, you get the. Alright. So, this evening, we want to talk about um, some theory, and we want to talk about addressing modes. Um, you will hear about addressing modes in your microprocessor course, or you may have heard about it in the microprocessor course, but I want to discuss four addressing modes for our that we can use in our PLC programs.
I'm sorry, sir. I
Um,
still don't have permission.
so allow and okay. Let me try again. Hmm. Oh, wait a little bit. So this will give permission. Give the wrong person permission to record. Get it now?
Yes, sir. I have it.
Alright. Alright. So in a discussion about microprocessors, then you might see pop up the different addressing modes. But I want to discuss them specific to the PLC, which basically is a microprocessor. So the addressing modes are ways in which you can carry out your instruction. All right, so the first addressing mode, which we're going to talk about, is the one that we have been using. It's called immediate operand. So, um, and let me use one example so we can carry that one example straight through. An immediate operand says that the value to be operated on is located in the instruction. So the value that we're going to operate on is located in the instruction. So number sign 500, that's the value that we want. The instruction is the timer. So that is our instruction. So in immediate operand, is the timer number one, or you see move, as we're going to discuss in a little, or you see compare, or you see whatever it is, but the value that we're going to operate on is located in the instruction. All right. And so this little box contains the box contains the instruction. Timer one is the instruction, and number sign 500 is the value to be operated on. So that is what we have been using for the past couple of weeks. So that is immediate operand. So the next one that we have not used, and so this evening now we need to discuss that now, is what we call direct addressing. And let's use the same instruction. So this one now is that the value to be operated on is found in the memory location in the instruction. So this D00 is a memory location. So what it's going to do is that we are going to go to our memory in a little bit. So when we go to the memory, what you're going to see now, when you go to that location in the memory, is the 500. So it's timer 1, and then it's going to go. The instruction says go to D00, and then you find the instruction in the memory. So it goes to D00 and finds the instruction in memory. So let me just let me bring up the PLC. And so make a little bit clear what I'm talking about. All right, so this is a service where you program the PLC. And so we are saying that you can program a PLC and then so let me just indicate what we are saying. Or try to. All right, so first thing, like we said, timer. One, and we are saying it's D0000. Right, so that is the instruction with direct addressing. So instead of the number, we put the memory. So let me go to the memory now. So the memory, if you go over to the side, you can go and look at the memory. So the You see, all of these are memory location, different registers that you have. But we are talking about the memory for the PLC. So the memory for the PLC now. You see that it says D00. So the box that is highlighted now, that is the memory location that we said that the address is supposed to be located in. There are, let me not tell a lie, let me just look. I have it a good source that there are 32,769 memory locations. No, well, like 32,767 memory locations in your PLC. So there are 32,767 places where I can store values. Now, if I right click on it and go to properties, I can decide what kind of values that I'm going to fill in. But please note, by the way, you see in the screen?
Yes, sir.
Okay. So the default is hexadecimal. All right. So if I put in a value inside the space, then the default is going to be hexadecimal. But I would choose however I want the value to be displayed. All right. So if it's decimal, I would click decimal, okay. And then now I would put in 500 inside there. And then go back to my, so that is where I store the thing. And then I would go back to my program. Okay. I'll go back to where is it? I don't know why it is that it has disappeared here. All right. All right. So
Afternoon.
afternoon. So I can write the program like that. TIM1 and data memory area. All right, and store the value in the data memory. So let me see if it is not there. I didn't save it. All right. So let me go back to what I was saying before. So yeah, those direct addressing and immediate operand. So those are two modes that we can use. So so as we are saying, you put in the timer one, and in direct addressing, the value that you want to so it's going to go to the instruction and then go to the find the value. Whereas in immediate operand, it's the instruction, the value is already in the instruction. So therefore, because you have X'd out one step, then immediate operand is faster than direct addressing. All right. So just the immediate operand is faster than direct addressing. As the value is immediately available. So the computer has to go through one less cycle. All right, so I have said that immediate operand is faster. So if you want to do the thing quickly, then so be it. But so what would be an advantage then of direct addressing? You know, what would be a reason for me to choose to use direct addressing rather than immediate operand? So let me use a practical example that currently exists. When this is just me doodling, this is not a part of the. So in Jamaica, our stoplight system, everything is controlled and that's supposed to be allowed. All right, so everything is controlled. All of the stoplights go to our PLC. Every one of them in Jamaica go to this PLC rack that is located at the NWA office, the one in halfway tree that is beside the fire station and the courts. So all of the stoplights, including the one in Mobile, the useless one in St. Elizabeth. Well, there's two of them in Santa Cruz. The one that you leave in Santa Cruz to me is useless. All of those stoplights, all of them go to our PSC in NWA. The control in a control room at the works agency. Now, in halfway tree, we have an intersection and we have a stoplight. Now, you would agree that in the mornings, should I use halfway tree? No, we could use the one right Devon House. In the mornings, the traffic flow. Where is that? Old Hope Road and what this road here is, I don't remember. But the traffic flow is of such that in the mornings, it is very, very heavy. Or, yeah, let me use an even better example. Not that one. Arden Road. So this is Old Hope Road. And this is Arden Road. All right. In the mornings, the traffic coming off of Arden Road is light, but in the evenings, it is very heavy. So in the evenings, you'd have to give the green light coming off Arden Road to turn more time because of the very heavy traffic. In the mornings, you'd want to give Old Hope Road more time to allow the green to have more time on Old Hope Road. So between the morning and the evening, the fellow in halfway tree, the fellow at works agency, who was trained by UTEC, did a diploma in instrumentation, and then went to India and did transportation engineering. One of the things that he has to do is that he has to monitor some of these corridors and change the time on green um, based on the flow in the morning and the flow in the evening. Now, if you use immediate operand, then what you would have is that, let us say that you use immediate operand. So you have timer one, and no, so you have 60 seconds in the um, afternoon, 1 minute to allow traffic on Arden Road. And then you have to change it in the morning to 30 seconds. When you do that, if you try to use immediate operand to do that, then what you would have to do is stop the program, type in the value 60 or 30, and then reload the program and run the program, start the program again. So in situations like those where that is not feasible, you can lock down the program, type in the value, and then reboot and go through the whole all of the cycle. So what you do is, instead of doing that, is that you put a data memory. So what happens now? All you have to do now is go into the data memory and change the value in data memory. So that does not affect the program, the running of the program, because the program is going to go and say whatever value it finds in the data memory, that is what it's going to use. So you don't have to stop the program, you don't have to do anything. You just change the value in the data memory and the program continues. So any operation like that, if you have a manufacturing cycle and you want to pack 16 bottles instead of 12, or if you want, whatever the thing is that you probably want to change things in the system, but you do not want to have to stop and reboot. Then you use immediate operand. If you know that this thing is going to produce a batch of things forever and ever, I mean, not forever ever, I mean, but for a week or a month or whatever, when you put down take down the system for repairs and so forth, then you can do some upgrading and maintenance and change the values that you are going to be using. Because immediate operand is quicker, then it might be wise to use immediate operand. So immediate operand is useful in those situations where you you don't expect any changes in the system, or you're not thinking about any changes in the system. But um except over the long haul. But if it is something that might change on a weekly or daily basis, then it might be better to use direct addressing. As the fellow in at NWA. In the mornings, put type in 30, in the evenings, type in 60. They have other sophisticated ways of doing that, but that is something that you would use direct addressing to do. All right, so that's the second addressing mode. The first one, timer number one, 500. Second one, you go to the data memory. All right, the third addressing mode is indirect addressing. And in indirect addressing, the add sign. So in indirect addressing, the value to be operated on is found at the address that is in data memory. So here's the thing now for indirect addressing. What is happening now is that if you have your data memory, when the instruction goes here, is let us say that it sees 40. It is then going to go and leave so data memory, it goes here, it finds 40. It's then going to leave and go to 40. And at 40, it will find number sign 500. So the address in the instruction, it go to the instruction, and that address that is found there, it goes to that address and finds the value there. So at this point, person usually asks the question. So ask me the question that is hopefully in your head.
Sir, can just go back over that, please?
Okay. We say that it goes. Huh?
We move from the D0 to 40 and the 40 to the number sign 500.
So what I'm saying is that when you see the @ sign, what it's going to do is go to data memory 0. So you go to data memory 0. And what the @ sign instructs is that is indirect addressing. So indirect addressing means that you go to one address to find the next address that you must go to. And then when you go to the next address, then you find the instruction. One of your brethren explained it this way. Say, what that is that you go to the brethren house and the brethren will tell you where the young lady house is located. Maybe a little bit down the road from you, from him. So you go to the brethren house and then the brethren tell you where you must go. So that is indirect addressing.
Oh, sir,
So when the @ sign is there, I do hear you.
Sir, it's like a pointer system in C++.
All right. See, there's like a pointer system in C++. All right. So this here points to the data location. All right. So you go to 0, find the address, and then go to the address to find the value. So most times when persons understand this now, they ask, what is the point of this? I don't know if you're wondering that. What would be the point of indirect addressing? So do you see the point of, can you think of a reason why you would need indirect addressing? If you can, if you don't see, tell me say you don't see no point in the indirect addressing. So we can,
Me not see it, sir. Me a try. Me not see.
you know, see why you would have indirect addressing. You can, meaning that you can think of a scenario, just like how we explain a scenario with direct addressing. You think you can think of a scenario where you wouldn't need indirect addressing. So you go to the address and then the address, go to the next address and then have the instruction. You can think of any situation where you might want to do that or would want to use that. Anybody have any?
Sir,
Mm.
I'm not sure if it's applicable in this case, but I'm thinking of a hyperlink situation where we would click a link and that link would bring us to a next page with more information on the link we selected.
Okay.
That'd be a similar scenario.
Kind of. Alright. But when we give you the scenario that because this is an instrumentation course, so let me put together a scenario and explain where is it that we would use indirect addressing. Suppose so let me go over here with a little doodling again. So it's halfway tree. So let us say that you have here, whoops, no dragon. You had a furnace. You had a PLC connected to it. Your thermocouple. And it is controlling the temperature. So, and so we're going to venture a little bit into analog input. So, using the analog input on the PLC to put in analog values for temperature, and you're putting out, well, your heating coil can be an on-off situation. So it is controlling the temperature inside here, the PLC. So what you would hear is what the program would look like. So so we're using it to teach some instruction, some coding instruction. You see this P1S, P with the 1 and the S. Let me go back to and explain. MOV means move. 200 is the instruction to, just like how we say 00 is one switch, 200 is an analog input, which means that it is going to take whatever value that's going to have. It's going to take a signal. So we'd have to condition the signal to be one of the following. Not 0. 1 to 5 volts, 0 to 10 volts, minus 10 to 10 volts, or 4 to 20 milliamps. So every sensor that we have to take the, so if whether it's pressure or temperature, whatever it is, we have to condition the to accept one of these, to convert it to one of these range of values, either a current, a 4 to 20 milliamp current, minus 10 to 10 volts, 0 to 10 volts, or 1 to 5 volt signal. So it's going to move that and store it in the data memory. Whatever the value is, it's going to convert it to an hexadecimal value and store it in the data memory. And this switch is a 1 second. The P1S is a 1 second switch. So it says every second. It's going to close every second. And every second is going to move the temperature that is on the in the furnace into data memory. 0. So we understand what this instruction is saying. So let me just go pause that a little bit and go back a little bit to my PLC program.
Wait there, sir. Can let's go back to that, please?
Right, so
Do your thing now.
all right. So let me just make a point here, which, see, when you are this thing here, not all right. If you look at all the different switches that you can have, we type in a value to say 000.00.00.01, but there are certain built-in switches that you have. Now, in the past, you had to remember the code for these switches, but now they have upgraded the program. So the first one says every 0.02 seconds, 0.1 second, 0.2 second switch, and the 1 minute switch. So it closes every minute. And you have a 1 second switch. Leave these for you to read them in the book. We're going to talk about equal. Leave these. First cycle means as you turn it on, turn on the machine, and so forth. Error, and so forth. Greater than or equal to is GE. Greater than, because we still talk about these, that's why I just pointed out these. Less than or equal to, less than. Not equal to. So I don't know what N mean. All right, well, leave it for to figure those out. Some of these out. All right. So you have a whole set of switches that you can put in All right. So all of these are switches that are coded into the processor, and you can select them to use at any time that you choose. So under normal circumstances, if it was a real furnace, then you would be using the 1 minute switch, not the 1 second. But for the purposes of our discussion, we just put that there. So if you want a switch that closes every minute, then I have one, and so forth and so on. So let's say you have the 1 second switch. Oh, the 0.1 second switch, this 0.1. But you have the 1 second switch as well. And then I was saying that you had a command that says MOV, move. And then we're saying that it will be 200 into data memory. Just checking. Okay. It's a valid instruction. So move 200 into the data memory. Let me. I'm dealing with several things at once, so please bear with me. We're trying to know. I'm just going to talk about the. If we were in class, we could have just show you. All right, okay. Let me just go to one other thing that is kind of off topic but relevant. Give me a second here while the thing loads. All right. It load, but it's not what I want. All right. One more second. Don't go anywhere. I'm just trying to find the right picture. Okay. All right. All right. You see the diagram, the PLC on the screen? Tell me yes if you seen it.
Yes, sir.
Yes,
Alright.
sir.
Yes, sir.
So I just wanted to talk a little bit about the analog input. All right, you see this part over here? The political part over here?
Yes,
Those are,
green.
yeah, green and orange. So first two, how we address that in the program is 200. The next two inputs is 201, and so forth and so on. 202, and the last one is 203. One of them is positive. One of them is positive, where you put the positive, and one of them is common or ground. So for each of them, when you're addressing them, one of them is positive, one of them is common. So these are the inputs. And then the output is 201. Sorry, not 201. The next one is 201, not the output. So this one is 200, 200, 200, 201, 202, 203, 204, 205, 206, 207. But these are outputs. Now, the PLC, this, it doesn't have, this is where you see the thing that says peripheral, you have to lift up that, but it has a set of pins like this that tells you whether you're going to use current as the input or voltage. So you have to set the pins, but we'll talk about that later. So what I'm saying is that you connect your wires to the analog input, so when you see the thing that says move, it's going to take the value in, whatever value it current is going to be stored, it's going to be stored in the processor as a hexadecimal value. All right. So move 200. So whatever is connected to these two pins here, it is going to be stored. The value is going to be stored in data memory. So you have 4 inputs and 4 outputs on the PLC. So back to my little doodling here now. So you have the instruction, the thermocouple, and your analog input, and every second you're going to move the analog input value in. And I suppose you may want to do some things with it. Compare, CMP means compare. So I want to compare D0 with, this is a line, 1100 degrees Celsius. Let us say that is the furnace. Why this is a lie, but I'm going to stick with the lie for the time being, and you can move me off of it until maybe 2 weeks from now. This lie is that you're not going to put 1100. You're going to convert this to a hexadecimal value that is based on the whatever the input is. But I'm using this 1100 degrees C for the time being. So compare D0. Sorry, the value in D0. And then when you make a comparison, you always want you make a comparison because you want to take an action. Yeah, you want to say mine is bigger than yours, therefore. So let us say if it's less than or equal to and the heater is 100. So this is the heater. With less than or equal to, then you turn on the heater. So this part says if less than or equal to, turn on the heater. So this less than or equal to flag. We call it a flag. So every 1 second you're going to compare the value that is in D0 to 1100 degrees Celsius. With less than it, you turn on the heater. All right. So now, what all of that have to do, because I'm stuck on point 3 here, but I'm setting up a scenario here. So you're going to take the temperature and you're going to store it to the PLC. So 1 second, the temperature. So let us put together a scenario now. The temperature is 1000 degrees when the first sample is taken. Then is 1005, and so forth and so on. So every second they take the temperature, it is a new value. So it is 1100 the third time, and it's 1200 the fourth time, and action is taken, and it's 1150, and so forth. So the temperature, this is the values every second that is being moved into D0. Now, if it is, that's fine. But suppose now I want to create what is called a stack. Anybody remember what a stack is from C++ class or microprocessor class?
Would it be okay? I want to make sure I'm not mixing up something. Would it be basically like whether if it's first in first out or first in last out? Is that what you're referring to?
All right. So when you're creating a stack, those terms are important. First in first out or last in first out, and it is relevant to the creation of a stack. So what a stack is that it's going to create the consecutive set of data ordered. So the data that I have here is going to be stored in memory location. So this is D0, and let us say D02, D2, and D4, and D6. So it's creating a consecutive set of locations for, remember. So what does that all have to do with indirect addressing? Because I've gone way out with the indirect addressing. So here's the thing. So if the scenario that I point out there, whenever, every second, what is in D0 will be overwritten. But if I want to create a stack, meaning that I want to say keep a list of all the temperatures, then what I would do is change this to at D0. And then now, I would have another every second, and this means increment. Or add one. So now, what does that do? The plus plus mean increment. Give me a second to make. I usually tell lie when it these things. So give me a second. Let me make sure. So I am going to now embarrass myself on screen. I'm going to check to see if make sure it's not no lie I'm telling. Yeah, so 1 second. They say every second. This was 0.1, but 1 second. And I'm going to increment. Just checking to make sure that I'm giving you the right. So I'm going to say all right, binary increment. Let me try I N C. No such commands exist. It used to exist. So one of the things that I would like to tell you is that every year you need to update yourself on what the instructions are. So I'm telling you increment. Yes, binary increment. All right. So now, what does that do? So let us go back over this program now. And where is my? Let me make it smaller so we see everything together. So now, I move 200 and I have the outside D00. So I'm going to go here and then I'm going to move into my memory location at, I'm going to go here and say, it's going to say go to 40 and at 40, it's going to move whatever the temperature is into 40. So that is 1,100. What is it? 1,000 degrees. Clear this part here. All right, so it's 40. And at 40, that is going to put in the 1,000 degrees. Now, what is going to happen when it reaches this instruction here, the plus plus? What is going to increment D0? So what is going to be in D0? It's not going to be 40 anymore if you increment it. What is it going to be? May I ask you the question? Just make sure I'm not talking to myself.
If it's incremented, wouldn't it be 41 then?
All right, so 41. Now, so the next second come in, and what is going to happen now is that in the next second, when it takes the next sample, it's going to go, and it's going to say, you're going to go to 41. So you're going to move whatever is an analog input, 200 to not 40 now, but 41. So it's going to move the next and then it's going to go and increment 41 become 42. And so at 42 is going to put in the next temperature, and so forth and so on. So now you're not overwriting the value anymore, but you are creating a stack. And this stack is, how you go now? First in, I remember which one of them. Last in, first out, yeah. But we're creating a stack, so you're able to keep a record of what is the process that is happening inside your kiln. So you're able to maintain a record because you use the indirect addressing rather than direct addressing. If you're direct addressing, then you're overwriting your memory each time you take a reading. Right? But with indirect addressing, you can just with the increment, or you have other things that you can do. But whenever, let's work with increment. You can add one and then so forth. So the temperatures that are coming in will be as we have there, creating a stack. So this is what we call our stack in microprocessors term. I don't know if I get a feeling that I'm rambling all over the place. I don't know if you understand what we have been saying.
Yes, sir. Understanding.
Okay. All right. So that is the third method of third addressing mode that we have. So we have direct, we have indirect, and we have the fourth one now. We have immediate operand, direct, indirect, and the fourth one is indexed addressing. But I need to just make a little point here. Not that it is because I need to make sure that I address that issue as so that whenever we are going to go and do anything, we follow good programming practice. The increment was for the purpose. When I'm talking about increment D0, this here is a theoretical construct. I would not use increment on this. Here's why. When you have your data memory, when you're writing your program with the data memory, it is not advisable for you to use one cell. It is always advisable for you to block out 2 cells at a time. So that if the number that goes into the first, let's say that you have D0, what happens if, let us say that the number that is going into D0 is too large, then what the processor automatically is going to do is fill the rest of the number in the next cell. So let us say that the number is 4, 6, 1, 5. I'm just using this hypothetically. 2. When you start working with it, you see that it only holds 4 digits, or a 16-bit binary number. So if the number gets bigger than that, it's going to go over into the next cell. So usually, whenever you're doing, it's like we created this stack, it will be 40, then 42, then 44, then 46, then 48, then 50, and so forth. Just so that any value that I have, if it's too big for 40, it spill over into 41 is not a problem. So that is good programming practice that is usually done. So you just need to bear that in mind. So I wouldn't increment D0, what I would do is add two to D0 each time. So that it will go up by 2, right? But for the purposes of the explanation, and also I should make the point that if it is that you know that, as in most cases, it won't go over the two values, then increment is fine. And 41, 40, 41, 42, 43. I'm just telling you that the standard programming practice that you will see when you go out there is that you're going to skip. All right? That you're going to skip a cell. So if you store a value in one D0, then you leave D1 alone and go to D2 for the next thing that you're going to operate on, and so forth and so on. But if you know that, suppose you want more memory to use, then you know that the number not going to be bigger than 16 bits, then you can use D0, then D1, then D2, then D3. But just to reiterate the point, that is the standard practice is to skip one cell every time. All right, the fourth addressing mode is index addressing. And index addressing it's a timer 1, and it uses so what does index addressing do? The address where the value to be operated on and let me not use D0 because it will illustrate. Let me see. Let me use D2. So so you have 0, you have 1, and you have 2. And you go there and you find 40. So what you do, what we're saying is that you add these two, and you're going to get 42. So you go to D40. So this is D42. And you find the value that you are going to. So in that particular scenario there now, the value that you are going to use in the program and the value to be is found by when you're using index addressing is just add the value to the memory location. The value in the memory location to the value at the memory location. And so the new location is found. So found that way. So you take your D2 and you're going to go to D2. See the value that is there 40, add it to the 2, you get 42, and then we are going to go to D42. So you're going to go to D42 and see the value that is there. And you use that value. So that is what index addressing is all about. And same thing, you use index addressing to create a stack. Alright, so I was going to tell you Reliance, let me just once again. So these things are updated quite regularly. So what I will say this year might not be relevant next year. So let me just take out another instruction and then just make the point. All right. When we type it in the value, you see all of the various modes that you can use there. So you say at okay. See this one, I don't know if you've seen the other one. So here's how they have made a layout of me. So we have at, we have D, we have asterisk, and we have at. So so let me go back and correct something. D, asterisk, and at. So excuse me while I correct something. All right. So this one here is not indirect addressing is not the at sign. It's the asterisk sign. Sorry about that. So let me just correct it everywhere. Asterisk sign. And index addressing now is not the, I was using the hashtag, using asterisk. That one is the one that uses the at sign. So sorry about that. So the indirect addressing uses asterisk to indicate indirect addressing, while the index addressing uses the at sign. All right, so these are the 4 addressing modes that we wanted to discuss this evening. So I don't know if there's any question or clarification that you want to ask about. Any question or clarification?
Sir,
All right. Mhm.
you mentioned while you were going through the explanation that many of the conventional codes they're in the book. I was wondering if you had sent a book in.
I'm supposed to send a book in a group, but I have been delinquent. I haven't sent it yet.
Oh,
Phone has been giving me trouble for a week. I need a battery for it.
Sarah, when are we getting our first test?
What are the test that you normally get is a multiple choice. No, when we're talking about multiple choice, is when you come in and learn how to do everything, then we ask you to write a program and wire the PLC. So we have to teach you how to do those, and then we give you basically a practical test to say, you know to write up and you know to write a code, then basically. And then 2 projects. And then what I want to do this year is just give you a multiple choice test on top of it. So,
Sarah, Stuart is asking if there's an outline.
An outline?
Yes, sir.
Yes, there is an outline, but because there's a book that shows you some things about programming and wiring and so forth, but there's no textbook. So the outline that is there is not something that you're going to say, all right, if I talk foolishness, you can go read it in this book or that book.
Okay.
I've been searching for a text for years. But most of these things are either done by experimentation or passed on by word of mouth. So there's no like I said, I don't know of any text. All right. But the book, a useful book that I have, I need to send it to you in the group. Well, as soon as over the weekend, I need to get a new phone because this one here can't link to WhatsApp, can't nothing at all. Every minute it is going. And all people like me don't really. We're probably coming off of WhatsApp in the next few weeks. I want to come off WhatsApp in the next few weeks.
You're switching to Signal, sir?
Well, no, yes, everybody switching to Signal.
Okay.
But I don't know if Signal is any better than WhatsApp. WhatsApp wants to share the data with Facebook.
Signal is the most secure of them out of all three.
Okay. Yeah. But nobody had in up to January, February 2020, nobody had any concerns about WhatsApp. And then now in 2021, everybody have concerns about everything. All kind of weird things going on in the world. I don't know. So, when we get a new phone, I suppose I will download the Signals app and see what it is all about. So, anybody here download that and using it?
Me on the phone right now for download the new software.
Yeah. Well, me and you in the same boat.
The phone mash up just like you, sir.
Yeah.
Hmm.
Yeah, I'm currently using it, sir. It's pretty decent.
Yeah. So, what is your experience with it?
My experience so far is all good. It is just pretty straightforward as in terms of its purpose, but it has all the same WhatsApp features, just with additional security.
Okay.
So, yeah, but it's just really smooth and streamlined.
Okay. Because young people need to be because we are saying that we really have no data that needs to be stored, which is not true because our data, that our medical records, which we don't really want to know if anybody suggesting any medication to you while you're when you're on your computer. You don't want anybody suggesting so them know say you have this illness or that illness, or you're studying this or you're studying that. You don't really want people in your business. The reason why they want to be in your business is because they can make suggestions to you, say, buy this and buy that and buy that and buy that product and buy all of these other things.
That's true. A couple of years ago, a primitive version of this same monitoring system helped a guy figure out that his daughter was pregnant.
How?
Well, he was at home and he noticed that for the past couple of weeks that he has been getting actual mail, physical mail, suggesting like baby that has baby paraphernalia in there, right? So it was recommending diapers and baby food and all that stuff. So he looked at it and it was coming from Target. So he was querying Target, why were they sending him this kind of stuff? And they explained to him that, well, someone in your household has been looking at baby stuff.
Oh.
So the system flag it that say you're interested in baby items, so we just help you out. So you didn't have to look too far and ask him why if she's clean, she's clear, saying just look at your daughter and say, like, what's up? And so she what's up.
See, that is the thing about it, the potential for conflict with these devices. Because as it is right now, they say that don't send any email while you're angry because the next person who receiving it might press forward. You know, things like those.
Yeah, true.
Information and data that should be kept private. So why it should be shared.
You're seeing leaks all over the
we
place.
Might be thinking,
with, like,
we don't have anything.
Cases.
Yeah. we might think that, it's not anything big. We use they recommended deodorant to me, or they recommended this to me, or they recommended that to me. That information, some things are private. That should be private, you know. But anyhow, that is the digression. So if we're all right with this, then what I'm going to try to do is over the weekend, I should acquire a phone, or preferably a battery for the phone. I am very white when it comes to these things, like I said. If it's not, well, if it's not broken, don't fix it. And if you can't fix it, don't buy it. So, over the weekend, I will send the book in the group. and the first project in the group. All right.
Yes, sir.
So
Please do.
we stop in there today.
Sir, I have a question.
Mm.
Last two code them are right, you see? When we run them in a CX1, them not run.
What is telling you?
Wait, tell me again. The last thing I did, no,
Selected port does not exist.
yeah.
All right. I need to clarify one little thing, and then we get back to you via WhatsApp.
All right, sir.
Let me get back to you via the group. I need to clarify one little thing. I think that will start it out. All right. All right. So, we're going to continue on this via next week, and we want to talk about connecting to the analog input and what we need to do to connect to the analog input. What are the steps that we need to take? All right. So next week, I think I'm going to be at UTech next week. So I will try to go from there.
So no tutorial, sir.
The tutorial?
Yes, sir.
No.
Okay.
All right.
Sir, was the syllabus for the module sent in the group?
No, that's what I said. It is on the computer at UTech, so I've been there in a while, so I need to go up there and get all of those things.
Okay, no problem.
All right. So
All right, sir. Thanks for the class. Bless up.
later.